Hello and welcome to another of these Varomix tips and tricks and whatever we call this thing is. But I'm really excited because today we're going to do the amazing Hilbert Curve. Alright, so as you can see on your screen, we're going to do this amazing Hilbert Curve today. It's one of those curves that are called space filling curves. It's really interesting and I really love the subject of space filling curves, and I wanted to do this for a while, and I wanted to just solve it on my own, not just see how someone else did it. I did see a ton of research. I just wanted to solve it myself in Houdini. I did see somebody else solve it on other applications. I even solved it on my own on C++ as well to see how it works, what was the best method to do it in Houdini. And at the end, I just did kind of a combination of a few methods that I found online that just work for Houdini as well. Alright, so I can show you here. This is the curve that we're going to be doing. This is the Hilbert curve here in your viewport. You can see it. And you can see it's just all generated from Vex here. And the code is here. It's not a lot of code. It's just a few lines of code. There's not a lot of stuff. Which I wanted to do. I wanted to do it very simply. Alright, so we can see if we change the order here, which is basically the repetitions of the curve. You see, this is the first order, which is just starts with just 4 points. This is very important. These 4 points become basically the base of everything here. If I make this order 2, you can see it goes to copying basically the same curve, copies it to the 4 corners. Flips the top 2. In this case, I did it in this direction. Some other people do it flipped around, like just makes this the bottom, but I did it in this way. You just flip this 2 and then they get connected. As you can see, the points here, they're connected here. You're gonna see more about how it's done here, but just showing you the result of this and the basic theory around this. And you can see if you make order 3, now you copy the same curve again 4 times, but you copy the curve that you have, which is basically the previous result. This get copied to the 4 corners again. You see the curve, you can see it here, you can see it here, you can see it here, and you can see it here. And the same thing applies. You just flip the top 2, basically flipping them, and so they can be connected with the previous one. And then you continue doing that. Basically, this shape is now going to be the one that is copied to all 4 coordinates there. One, you can see one here, one here, one here, and one here. And again, that whole thing just gets flipped so it can be connected here and here. All right. I mean, this is just basic theory of it in a really fast way. I really recommend, if you want to understand this more, you go and see this video by the amazing Coding Train channel. So this is just takes you to, this guy is amazing. It explains everything so great about it. He does it in processing, but the theory is basically the same. You just change how you're using the code. But there's some pretty nice bits here, talking about bits. So this is something that we're gonna see. Also, how do you flip the bits so you can actually get the next iteration of the curve and stuff like that, which is really important to understand. But I really encourage you to see this. This is amazing. There's also the it's actually here. Yes, this 3 blue 1 brown video, which is also an amazing channel about math. You can see it here. It's this talks about the Hilbert curve, talks about other space filling curves, why you can see this is how this the Hilbert curve is created. Just the first step is just this guy, just one, and then you divide that into 4 quadrants, and then you have to flip these 2, as I said, to actually make it connect like this. So it's really cool. You can go and see more about this, the theory behind this, and why this curve is really cool. Actually, there's a bunch of good information in this video as well. I really recommend you see both videos, maybe even before following this one. All my research has been these videos, stuff online, math, and I just put that all together into one video so I can make this one specifically for Houdini stuff. All right, so hey you, it's me again. Just a quick interruption. If you're enjoying the content here in the channel, if you enjoy the content, if we have helped you in some way, please give us a like and subscribe to the channel if you haven't. This will help us reach more people and help more people figure out this crazy world of Houdini. So please just like and subscribe if you can. Now back to your tutorial. Bye. We're gonna code this all by hand, so I'm gonna be using the code that I already have, but we're gonna just code it from scratch. So let's just start doing that. So let's create another curve here. Hilbert Curve 2. Let's just call it 2. I'm gonna save this file. Save as this is version 2 as well. And it's really important whenever you're doing code that you just type the code. It's so important to just type the code. If you're don't type the code, it's really difficult to learn the code. So you should be typing the code. All right, so we're gonna generate the whole thing in Vex. So we're just gonna do an attribute wrangle. Let's call this Hilbert Curve, like that. And then move my keyboard a little bit closer. So to generate geometry directly from an attribute wrangle, you need to change the run over method to detail. That way you can just create points here directly. I'm not going to use this little window text box there to code because that is not really a code editor. So I have the external code editor installed, which is a free plugin, I guess. I can show you. It's if we search for that, is this guy from CG Toolbox. Makes this really amazing external editor. It's free, and you can just connect it to Houdini. You have these places when you can just use the external editor, which is so much better than coding in this little window. I do not like doing long code in this window. More than 3 lines is just, I don't use it for, because just, if you don't know how to set this up, I have go to mix-training.com, and I have a few videos that show you how to set it up. If you go to courses here, this Vex course, click here and view course. Scroll to the bottom where the courses are, and then you can just watch this preview, which tells you how to set up this environment to code it. This is like an hour long video. I don't really know what. No, it's not an hour long. Let's see, it's 23 minutes, which just tells you exactly why we're using that thing and all that stuff that you need to know and get set up to this. Okay, so if you haven't done that, let's just that is how you can get to where I am right now. So I'm gonna right click here on the name and say add expression, edit an external editor. That will open, in my case, Visual Studio Code with this file there. Let me close this. And I can type stuff here, and I can save, and it's gonna put the code there, and it's gonna complain that something's wrong, which is great. All right, so what we're gonna do is just start coding our stuff. Let me open my cheat sheet here. So first thing we're gonna do is just gonna create the order slider that we need. Needs to be an integer, so I use the channel integer expression there, and then just call it order. Don't forget to put your semicolon, save, and now we have this. Click this guy to create the slider, and there it is. I'm gonna put 1 to there. That's gonna be the first thing we're gonna do, but right now it's just gonna be just code for now. So we're gonna start doing the first 4 points that we need. Let me open the image on Wikipedia. Hilbert So this image is here, is what we need. We need the first order of this, which is this image right there. Let's just make this a little bit bigger. We need these 4 points, and this is going to be 0, 1, 2, and 3 points, all right? So it's really important. The order is going to be really important for this. And now you can see this is the second order, and you can see this is exactly what I was telling you. Like this little U shape, it's been copied here, 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 and here, and then the last two just get merged there, like just joined together. And then you take this shape and then you copy it again, and you can see that's exactly what happens. And this is telling you basically what's happening. This is the first order, and then this thing happens. These two got flipped, and then this get connected, and this is connected here. Like that's what happens there. Like I'm doing it in this way, in this C way, let's call it. It can be done in any order, really, in any direction. So what we need right now is to create these 4 points, so just to illustrate what we're gonna do. So that's what we're gonna do here in Houdini. So to add a point in Houdini, it's really simple. We just use the add point expression. You can see it needs a geo handle, which in what geometry you want to create that. In this case, it's just this. So you just put 0 to create it in this object. Let's call it in this geometry. The point number you wanna do that. It's basically not really a point number. It's gonna be a position here. So I'm gonna just set this to 0, 0, 0. So it's gonna be at the center of the world. This is basically the coordinates of the world, right? So if I save that, you can see now I have a pointer in the center of the world. If I enable points here, you can see I have 1 point there, which is great. We have 1 point. We need to do this 4 times now. So let's just do. I also want to save this into a variable because I'm gonna use it later. So let's call it pt0. It's gonna be equal to that to this. This returns an integer, so this is gonna be integer point number 0 actually. So I need 4. It's gonna be 1. This is gonna be 2, and this is gonna be 3. So I'm gonna set this is gonna be in the same geometry. I'm gonna set the coordinates for this. In my case, I'm not gonna use xy coordinates. I'm gonna use xc coordinates. So just think about, in this case, you're gonna think that this top view is basically a flat plane in Houdini, and then we have x and y coordinates going in this direction, okay? So basically the C is gonna become my y. So I want this like that. And then the second one, I'm gonna move it in the y direction. In my case, it's the C direction, whatever. And if I press save, there you can see I just created this one. I created all 4 here, and then I just moved this one. So in this case, I just moved this in C direction, and then the next one. Actually, I need another one. And then the next one's gonna be moved over here. So 1 down and 1 over. So it's gonna be 1 in X and 1 in C. So if we save that, you can see now we have this guy. And then then the other one's gonna be just moved over here. So it's gonna be 1 in X. So there we go. So we have 0, 1, 2, and 3. And this order, it's specifically what we want because we have this kind of U shape, and that's gonna become the U shape that we have when we merge these points or just make a line with these points. So next thing I'm gonna do is add a line to this, and I'm gonna create a primitive to hold these points or add them to a primitive. So that we do that with the add prim, and it's pretty simple. Just create a primitive. Again, geo handle is this one, and the type is gonna be the type. The polygon can be different things. It can be a closed polygon. It can be a line. In this case, we're gonna do a polyline. So we have a line that just goes a polygon that is open, basically, which creates a curve in Houdini, right? Or a polyline. So this is the polyline here. We haven't done anything to it. The polyline needs to have vertices, and the vertices need to have points. So we need to do that now. So let's say add vertex. The vertex doesn't need to be catched into a variable in this case. Again, we need it to in this geo handle. Which primitive number are you going to use? Which primitive is you going to use? We're just going to use this one that we created. And the point number is going to be what point number you're going to add. Let's put point 0 there and do that. So now we have 1 point on the primitive. So there's nothing because 1 point doesn't do anything for a primitive. It's there, but it just doesn't do any representation of it. So let's copy this and do 0.1. And now you can see we have a line between 2 points. And let's do the same thing for the other points. 2 and 3. And now we have this U. This order doesn't really matter. What matters is this actual order, I think. Let's just make sure that I'm not saying things. Oh no, actually, it does matter what the order you add the points, actually. That's the order that matters, how you add the vertices to the primitive, okay? So, in this case, it's 0, 1, 2, 3. That's what we want. That's exactly what we need. Now, we need to do order 2. Okay, so, we're not gonna do order 2 by hand. I mean, of course we're not. We're gonna do order 2 programmatically. This is where the Hilbert function comes into play, alright? So, we need to copy this function that we did, or this shape that we did, one here, one here, one here, and one here. We need to make it half the size, and then not half the size, actually divided by 4 or power of 2 size, and then flip this one, and the vertices are gonna be merged together automatically in a way there. So let's start by writing our own function to do this for us. So let's go back up here. I'm gonna do it all the way to the top. I always like to write functions in the very, very top of my file, because that way, if I use them below here, Vex will know where they are. So I'm gonna write a function that's gonna return a vector 2. So it's gonna return basically coordinates in 2D space. And this is just gonna call it Hilbert, because it's gonna basically generate the points for the Hilbert curve. We're gonna take an index as an input, and then we're gonna take an n as an input, which is basically a power. Then the function has to return something here. Okay, so in this case, we're gonna have a vector 2 that's gonna be returned. Let's just make that right now, vector 2. It's gonna call position, and let's just set it to something for now, so we can return something. So it's gonna be set to 0, 0, and then this function is gonna return that position, and that's basically the function is done. Basically, you can see Houdini is not complaining. This is fine, but these 2 values is what we want to set for all of these points. Basically, these coordinates are gonna become this output's gonna, those coordinates are gonna come out of this function. All right. So for this, we're gonna create 4 points, which is also gonna be become bits for the coordinates of the curve here, or of the Hilbert function. So we're gonna create an array of vector 2 positions, and then we're gonna open a bracket to create an array here, and inside here we're just gonna type the first point is gonna be basically exactly what is here, 0, 0, the first one, and then the next one is gonna be, and copy and paste this, the second one is gonna be 1, and the third one is gonna be 1, 1, and the last one's gonna be 1, 0. And you can see this is basically the coordinates we have here. 0, 0 is this point, 0, 1 is this point, so you can see 0 in x, 1 in y, 1, 1 is 1 in x, 1 in it's actually this one, sorry, 1 in x and 1 in y, 1 in y and y in x here, and then the last one is y on y, 1 in x here. So that's basically the positions that we have there. So in a way, we can just return this to this, and it will actually return the same thing right now, but we're gonna do a few other things. We're gonna also create another helper function here. It's just gonna be a really small function. It's gonna return the last 2 bits of a number. So let's just say last 2 bits. This could maybe not be specific function, but I just did it this way. So it's gonna take an integer and it's gonna return the last 2 bits of a number like this. There you go. So that's gonna just this end expression. If you see the video on coding train, he explains how this is gonna happen, and I will explain it a little bit here. So how this returns the last 2 bits. So basically, in this is what we have for bits. All right. So if you don't know binary numbers, now is the time that they become useful. So you have decimal here, and then we have binary here. So 0 in binary is 0, 0, 0, 0, whatever amount of zeros. 1 is just the first bit is activated, and that's 1. 2, the second bit is activated, that's 2. 3, well, you activate both and you sum them, and then there's 2 plus 1 is 3, right? And then 4 is just the third bit is activated, and that's 4. And this is going to be 8. So you can see 8 is the 4 bit is activated. But you can see we have exactly the same thing here. Like we have 0, 1, 1, 0, and 1, 1. And this is exactly what the positions we're using here. So what this means is that if I send to this thing, to this bit, return the last 2 bits, it's going to return these 2 guys. If I send this, it's just going to send me these 2 guys. So anytime I send this number, for example, it's going to return 0, 0, and this is going to return 0, 0, and 16 is also going to return 0, 0 or this one's going to also return 0, 0, because I'm just getting those 2 bits. And this, you can see, it becomes a sequence 0, 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, 0, 1, 1, 0, 1, 1. It becomes like this column, it becomes repetitive after 4 points. So that's really important for the repetition that we're going to have. Like these four things are going to be 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. And then the next column, you can see this, we're going to shift the bits later. You can see the first 2 columns, if you follow this, is 0, 0, 0, 0, 0, 4, 4, and then 0, 1, 4 times, 1, 0, 4 times, and 1, 1, 4 times. It's basically kind of walking the same numbers, but you can see this could be iteration 1, and then this is going to be for iteration 2. Maybe we use the second column and all that stuff, right? So it gets a little confusing, and it catches me a little bit sometimes. So don't worry if you're not catching everything there completely, but I recommend you see the videos there, and it will makes a little bit more sense what's happening there. But of course, also hopefully it makes more sense while we keep typing the code here, right? So after this, maybe I just start copying some pieces of code so we don't need to just be typing everything, and it's a little bit faster here. So I'm going to create a vector called temporary. From the positions here, we're gonna say from this position, give me the last 2 bits of this index, which is gonna be a number that's gonna be passed to this. So this index is actually gonna be the order number here. So this is gonna be, give me the last 2 bits so I can get the order of this. Okay. So this is a temporary variable that I just created here to hold the positions, which I just later just do this. I just pass the positions. I just get the X and Y. So just get the first element, the 2 elements, they just become X and Y values. So we just need those float values there. I'm also going to create another index, because in Vex, you can't assign to these variables here. These variables are basically read only, so you can't assign a value to that. So what I need here is actually to switch the bits, shift them to the right here with this expression in Houdini. You can see I can have the help here for it. So what happens here with this expression is, you can see this shifts bit shifts to the right by bits. So in this case, it's gonna shift this number that we got here. We just shifted by 2 bits. So that means that when here, this is the hardest part of this. So this, if we have this number, for example, if we shift that by 2 bits, means these 2 bits are gonna be moved to the right or in this direction. So the result of this is gonna be 0, 0, 0, 0. These two numbers are gonna be lost. If we have another number like this one, and we shifted 2 bits here, this number is gonna become like this. If I copy it here, I'm gonna shift it 2 bits, so these 2 bits are gonna be lost, and then I'm gonna fill zeros at the beginning. You know what I mean? Like, I'm just shifting them to the right, like just moving them. If we have this number, for example, it's real simple. It's just moving numbers, basically. This nothing scary. So this is gonna be losing the first 2, and then we just add 2 numbers at the beginning. Or if you want to see it like this, we add 2 zeros, but we need to remove 2 from the right. So we're just shifting it. And that means that we get this number here, which in this case, we're going to be 3. So that's it. That is because when we're looping, we just get the second iteration, and we're basically always working in a space of 0 to 3, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3 in a way. So I just shifted that here, and I created an extra index variable because, as I mentioned, Vex does not allow you to assign values to these input variables. They are basically read-only. You can see if I try to make this like that, Vex is going to complain that you can't really do that. I can just not do that, and you can see this sometimes works, sometimes it doesn't. I just don't want to really mess with the function, so I just created an extra index function there because we are also passing the index inside here, so it can be a little bit confusing. So I just prefer to just the bit shift index is this one, so it's a little bit clearer what's happening. So now we're gonna create the loop that is basically the core of this function, really. So I'm just gonna copy it. So we start with a for loop. And close the for loop. And the for loop is gonna be that n, this variable n, it's gonna start at 4. It's gonna be equal to 4. Okay, so we're gonna start at 4, and then n is gonna be if n is less than or equal to n, which is gonna be this power number. We just do whatever is here. In the first case, it's gonna be 4 points, so it's gonna run once. And if that, when this loop runs, this just get multiplied by 2, which in this case, in the first case, will be 4 times 2. It's gonna be 8. So this is just not gonna run the next time because it's just the second time it is gonna run, and then so on. Because the second time is gonna be 16 really, because it's not duplicating. It's just power of 2. The first time it's gonna be 4, and then the next time it's gonna be 4 times 4. It's gonna be 16, and then the next time it's gonna be power of 3. It's gonna be 4 times 4 times 4. So yeah, it's gonna be. I think it's what's gonna happen. So yeah. So now we're gonna create another variable here, another n inside of here. We're gonna create n2, which is just n divided by 2. So we're gonna use that to know it's gonna be basically the length or the separation between each one of the copies. You can see, remember that we said that order 2 is gonna be moved like 1 copy here. So that's basically how much it's gonna need to move it in the n direction in a way. So we're gonna create 4 cases here for each one of these points. So basically these 4 positions or coordinates or cases. So you can see, if the last 2 bits of this index that we just said, it's 0, which this one's gonna be 0, right? the next one's gonna be 1, the next one's gonna be 3, and the next one's gonna be 2. Again, because we're working in this other order. If we didn't put 3 before 2, you can see this would just make a different connection here. Actually, it's failing because I have some error. Oh yeah. What did I do wrong here? Maybe this. Oh yeah, there is that. Let me see. Let me just do this so I can. No, we're not using this yet, so this is not gonna work. So, in the first case, for the first curve here, or the top left quadrant here, is gonna be just gonna set that the temporary variable. I'm just gonna fill it with whatever value is in x, or in this case this, and then just gonna say x is gonna be equal to y. In this case, it's 0 anyway, and then y is gonna hold the temporary variable value 1 or 0 actually from here. So this getting it from here. It's not getting it from here. It's getting it from here because we set this value here, right? So this is basically gonna use this quadrant. There's not much gonna happen for that quadrant there. For the next one, we have an else statement here. For this one, which is gonna be 1, the quadrant 1, which is this bottom left here. For this guy, we are going to just x is gonna be x, but y is gonna be y times this, which is what I said, the distance from here to here, which is basically getting from this n variable. In this case, let's say it's gonna be 4 divided by 2 is gonna be 2, so it's gonna move it down here by 2, because y, I think y it's still at 0. So it's gonna add 2 to that, and it's gonna move it down here, right? Okay, so in the next case, it's going to be here. So now this is the third case. So this is gonna get when this is 2, which is working on this quadrant here for this 2. We are going to actually x. We're gonna move it over here. So we have to displace it to this in this direction with the same amount of distance that we were getting here. And then y, we can also write this top one as this y. I mean, I sometimes wrote it this way, but sometimes I just wrote it this way. This is exactly the same kind of expression. So this gets rid of this part, basically. If you want to write it like this, you don't have to repeat the variable there. This is basically exactly the same thing. I just write it. Some people want to write it like this. For example, this is exactly the same as this, but it's up to you how you write it. So in this case, we are just moving the x value, I mean the c value over here. My thing just got just failed for some reason. I'm not sure why this is failing, if this is actually right. Nothing wrong is happening in this function, is it? I think I just need to finish this. Yes. This else if thing. Now for the fourth case here, we have this. Whenever this is 3, the index will be 3. We set the temporary variable to value to x. So we're basically just storing the current x value, because we're gonna modify it here. We're gonna subtract this. So this is where we're flipping the two values, minus x. So we can move it over here, but we're flipping it. And then also here, we're just we're flipping the some values, and then we're flipping the x as well here. And then we set in the x, moving the x to this in this direction. So this is flipping the points, and this is moving to this quadrant over here. So let me see why this is not working. And when we finish this function, really, we just need to set this in this loop that we're running. We just need to shift the bits again. So we need to basically run the next iteration there, just flipping the next bits. And then we have Actually, these guys are supposed to be up here. That's why it's failing. It's supposed to be over before the for loop here. So this is first here. So that's why it's failing. And then we just flip the bits again. I mean, just switch the bits to the right to continue in the next iteration. And then we pass that position. And when we return it, in this case, we need to pass the position. We build this X and Y position. So we need to pass X and Y here, not capital, actually, X and Y positions, right? I mean, I know this is a little bit weird, but if you try it, if you code it, it's gonna become like just you're gonna understand what's happening there. Okay, this is the key part of all this effect basically, or this function. So now we're gonna create a little bit of other code that we need to replace this with that function that we just created. So we don't have to type all these things for adding those points to the screen, which is what it's doing the point adding for now. So let's just remove all this because that's not how we're going to do it. We're going to create a for loop, and this for loop is going to say it's going to start at I equals to 0, and then we're going to say if I is less than total, which is going to be a variable we're going to have here. Just call add to I there. It's a regular loop. So let's create this total thing that we have here. Let's give it some space here. So we're gonna create a variable that is gonna be basically the power of the function that I was talking about. So this is gonna return an integer, or just this to make this a power of something. We said this power function says what number you wanna do the power to, this, and then the exponent for this is gonna be the order. So basically, this order, when it's 1, is gonna give us the power of 1, which is gonna be 1 by 1 times 1 is gonna be 1. This is gonna be 1, and the next one, 2 times 2 is gonna be 4. And the next time is gonna be 3 times 3 is going to be 9. So this is going to give us the power of 2. But just to make sure this gives us an integer, we're just going to wrap this in an int function there. Okay. And then the total is going to be the square root of that. So we just say in total is going to be equal to the n times n. So that's basically, it's the square root of double n there, right? All right, so that's the total that we're gonna have. In this case, we're gonna have, it's gonna be, okay, yeah, this is fine. So this is gonna be a total. In this case, the first case is gonna be just 1. So we are going to now run this variable that I'm gonna create here, which is the current. Let me see, where did I create that variable? Oh yeah, this is we need to create two vector variables. Vector 2, we need one that's going to be called previous, and one is going to be called current, and this all two are going to be just initializing at 0, just the previous and the current point that we're going to be doing there. So the current is going to be equal to calling now our Hilbert curve there, or Hilbert function, which takes an index, which in this case is going to be this index, and then the n is going to be this double n that we just created. So that's what's going to give us those points that we need. So we actually can just rebuild what we did with what's just delete. Just create one point, add point with this geometry, and then the second one is going to be set to so we before we just set this to like this, and then we changed the coordinates manually. Now this is gonna go to the Hilbert curve, and this is gonna return a vector. So this is gonna get the x value of the return value, and put it into the X, and then we're gonna get the X value and put it into the C. So just because we're working in a top-down way here. So what is this complaining about? No, nothing's complaining. It's just nothing's being generated yet. So now we just need to add the vertex as before. This little vertex that we're creating, or those little vertices that we're creating, to the primitive again, and then we just pass that PT there, and now you can see we have something, that something's happening. 0 and 2, it's happening there. Something's wrong right now, but let's debug it and see. Oh yeah, because I passed 0 here as well instead of 1, so this is getting the same X value. So now you can see this function, or this loop, is creating our 4 points, because we just passed those points to there, and it's just creating the order 1 Hilbert curve, because we have order 1 here. So let's see what happens if we move this guy and make it order 2. So you can see we have actually, let's zoom out. You can see now we have actually order 2. There it is. It's copying. It's making 1 copy here. Let me just do grab my writing thing. Oh, I don't have my, anyway. So this is order 1 here, which is actually being flipped, but it's fine. So you can see 1 curve is here, 1 curve is here, 1 curve is here, and the other curve is here. And then they are being joined in this, and this are just unions of that, right? Let's just delete that horrible drawing that I did. So this is basically done. You can see it's growing because we're not changing the scaling, but you can see now we have one. Let me just select edges. We have one version here, and then the other is over here. The other one is here. The previous order is, and they are being. So this is actually working. It's basically we're done. We are totally done at this moment. But let's just make it a little bit more. So it's, as I mentioned, the meat of this is on this function, this Hilbert function, which just creates all those positions, grabs the correct order, the correct index, and does the actual magic there. So you can see now this is just looping through how many times we have this number here, and then just creates the next order, the next order. In this case, we can just keep it going, and it's gonna be doing that amazing thing. Just to keep it in one place, what I did is I just added this match size node. So we can just say scale to fit 1:1. So we just have this in a 1:1 grid, and I like to have it in minimum here in justify X and C. So it's actually here in this quadrant that we've been working in. So now if we go back here, and you can see, let me just open this, just create a null here at the bottom, so I don't see that outline there. Just open these parameters like this, and you can see now, let's just click here. You can see if I open this to order 1, that is what we have. Order 0 would be just 1 point, of course. I think it's 1 point. Is it? Yeah, 1 point. So order 1 is gonna be that. Order 2 just copies that to the 4 quadrants and unites them. Order 3 just takes the previous and does the other thing. Order 4, order 5, order 6, order 7. So you can see how this is filling the space, and that's what the nature of this space filling curve comes from, right? So you can see order 10 is just doing a lot, like a million points there. So this is great. I love this thing. Let's just make it a little bit more fun with adding a little bit of color. and then we are done. If you're happy up to this point, you can just say, okay, you know what, I'm done. I'm happy. Everything's cool for me. I'm going back to whatever I'm doing. So, but we're gonna add color to this. Let's add. I'll just make everything black to start off, and then I'm going to add here. After I made this at the vertices, I'm gonna create a float. I'm gonna call it hue, and then I'm gonna say I'm gonna fit some value, which is this value is gonna be this index that we have here. I'm gonna fit it between 0 and the total number, and the value is gonna be from 0, 1 to 1. That's gonna be my hue, and then I'm gonna pass that color to the curve. So I'm gonna create a color here. I'm gonna use the HSV to RGB function. RGB, no, not that one. HSV to RGB function, and then we create an HSV value, which is just values from 0 to 1. The first one for me is gonna be the hue, and then the saturation, and the value is gonna be 1 and 1. So that is that, and then nothing's gonna be applied until you say set attrib set attrib like that, and then for what geometry, this one, and then what attribute you're gonna make it a class of. This is gonna be a point attribute, point. Then the attribute name we're setting is the color. The element number is the current point, and then the vertex number is 0. The value is that color we created, and the mode is set because we are setting this attribute. Return here, and then we put the semicolon there, and then you have functions there. Now at the end here, I did this previous to current, which now I'm thinking that I don't really need this actually. This function here, this assignment, but yeah, maybe I don't remember why I did this anymore. Is this needed? I don't remember exactly why I did this previous equals to current. Maybe no, because I'm not even using this variable anywhere. So yeah, this is not really needed. So let's just get rid of this. Yeah, sometimes when you're investigating stuff, you do things and then you just don't really need them anymore. So there we go. We have the color working now. You can see it's very nice. Adds color to each one of the points. Then if we raise the order, you can see the color is going to be nice there. Raise the order again. You can see this one's going to have one color. It's kind of grouping the colors by quadrants in a way, a little bit. It's giving it like a shading for that quadrant a little bit. But as you go to more, you can see this really nice gradient. Also, what you can do once you have this done, you can just do crazy stuff. Like you can just do a curve, because this is just one continuous curve. This is just one curve all over this. As much as you raise the order, it's always going to be just one line. Like it's one continuous line. You can see this curve is just really, really, really fun to play with. How this is just doing this for one single curve, which is just great. I'm gonna make this 0, and I like to do it like this, like it's just kind of growing from the beginning, or the top left in this case, all the way to the end, it's amazing. I love this. We can actually let me just copy an expression that I wrote for this curve, and you can see I'm just getting the frame number divided by the frame end times 1 here, which is basically just this number divided here. So I just make like a range, and then I just have this times 1 because I can make this times 2 and go faster. See, I make that faster when I hit play on Houdini here. I can just play that. If I wanted to play just at the regular time or slower, I can just make this value smaller. And you can see the Hilbert curve just being drawn in real time, and that's the order of the points in that direction. They are completely in that order, which is just great. I love this kind of functions. All right, I think that's gonna be it. Awesome. So we did the Hilbert curve in Houdini, just lines, and after this point you can just take this to whatever else you want to do in Houdini and put it into whatever. Make it into a mesh, put it into Roberto, put it into whatever. I don't know. I just wanted to make this curve in Houdini because it's just basically a thing that I wanted to do, and some of you might find it useful, some of you might find it fun to do this kind of math things in Houdini, experimentation. I don't know. It could be useful for some things. Maybe add something in a head-up display or something. I don't know. All right, guys, this is it. Hope you enjoyed this. If you like this, please like and subscribe. And if you haven't subscribed, just subscribe, please. Like the video, share it with your friends. All those nice things that help us get more education for more people. All right, thank you again. This is your friend Varomix, and I will see you in the next one. And let's keep learning together.